All right, let's remind ourselves what linear relations, what do we know about them? We know that there's an x and a y, so two variables. We know that there's all of the variables only have an exponent of 1. And if we think back to quadratics, quadratics has an x squared value, but linear is just y and just x. And then when we graph any of these linear expressions or any equations, we will get straight lines. So a new term is a system of linear equations is just having two or more on the same graph or two or more listed like in this example here. We're just going to stick with two currently, but we could do more later. But you're just going to focus on points of intersection or solutions to two lines or two linear relations. A solution is a coordinate or a point, xy, that is graphically it's where they meet, and algebraically it's taking this and subbing it in and seeing if it satisfies both linear equations. So let's try this example and see if 1, 2 is a solution to this system. So we are going to check this first equation. So if we look at the left side, that's 2x plus 3y. And we know the right side is supposed to be 8. So if I sub in 1 for x and 2 for y, so there's 1 plus 3 is 2. I should get 8. 2 plus 6 is 8. Awesome. So that means that yes, 1, 2 is a solution for equation number 1. We'll call this 1 and we'll call this 2. And then if we take the second equation and we look at the left side and we do the same thing, so 5x minus 2y, and I take my solution 1, 2, and I sub that in for 1 for x and 2 for y, 5 minus 4 equals 1. And the right side of this equation, the second equation was 1, and it also works. So yes, 1, 2 is the solution for equation number 2. Now, the ink in red you do not have to include. You can just say, yes, it satisfies this one, yes, it satisfies that one. So you've checked algebraically that it is a solution.